Okay, now we'll discuss the normal distribution. And if a continuous random variable has a distribution with a graph that is symmetric and bell-shaped, as in figure 6.1, this is figure 6.1 down here, so it has to be symmetric and bell-shaped, like in figure 6.1. And it can be described by the equation in formula 6.1. So here we have formula 6.1, and we have this equation, quite a complicated equation. We say that it is a normal distribution. Now, in practice, it's going to be difficult for us to check to see if a distribution is normal or not. So, for the most part, in our text, we're going to be told whether or not the distribution is normal. So, there won't be any question as to whether or not a distribution is normal. It'll either explicitly say so, or it won't. If it doesn't explicitly say that it's normal, then you can't assume normality. All right, so this equation is very complicated and not easy to find values for. So instead of using this formula, what we do is we're either going to use technology like the TI-83 or 84 calculator, or Excel, or we're going to use table A2. Table A2 is in the back of your book, in the appendix, and it has a bunch of values for the areas under the curve and the z-scores, actually, or the values of, not the z, well, yeah, the z-scores. There's going to be a relationship between the x values from this formula and the z-scores. And one thing we need to remember is that the total area under this curve, the total area, the total area is equal to 1. We're going to need that information as we go along. But the area underneath this bell-shaped curve, the total area is 1. All right. Now, this is the normal distribution. Notice the only adjective here is normal. Here is something, a definition for the standard normal distribution. So notice they're adding a adjective here, standard. So the standard normal distribution is a normal distribution, but it has these three properties. The graph is bell-shaped, just like in figure 6.1, so it's the same bell-shaped graph that we have here. The mean of the standard normal distribution is equal to 0, so that's key. The mean is equal to 0, so if we're talking about a standard normal, the mean is 0. That's not true for all normal distributions, only for the standard normal distribution. And in a standard normal distribution, the standard deviation is equal to 1. Once again, not true for all normal distributions, but in the case of a standard normal distribution, it is true. Okay, in this section, we develop the skills to find the areas, which are probabilities or relative frequencies, corresponding to various regions under the graph of the standard normal distribution. In addition, we find z-scores corresponding to areas. So we're going to do it both ways. We're going to be given a z-score and asked to find the area under the curve, a certain area or a certain region, and we're also going to be given an area and asked to find a z-score. So we're doing this in both directions. Here's the definition of the standard normal distribution. It's pretty much the same as the definition of the normal distribution, except in the standard normal, it's given that the mean is 0 and the standard deviation is 1. So if you see a normally distributed random variable with a mean of 0 and a standard deviation of 1, automatically you're dealing with this standard normal distribution. The standard normal distribution is a normal probability distribution with a mean of 0 and a standard deviation of 1. The total area under the curve is equal to 1, just like I just mentioned. Okay, so here's an example. And here's the table I was talking about, table A2. This table gives you the area to the right of a certain z-score. So you have a z-score. Remember, z-score was a measure of how many standard deviations away from the mean a certain value was. So given one of those z-scores, this area, or sorry, this table will give you the area under this curve to the left of that z-score. So this table gives area to left of the z-score and underneath the curve. But that's something very, very important. This table can only give us the area to the left. But remember, the total area under this curve is equal to 1. So if we wanted the area to the right, all we'd have to do is subtract that area from on the left from 1. And here's an example. This example says in exercise 9 through 12, find the area. So right now we're trying to find the area, the shaded region. The graph depicts a standard normal distribution with a mean of 0, very important, mean of 0, and a standard deviation of 1. As soon as they say that I have a normal distribution with a mean of 0 and a standard deviation of 1, I know that I can use this table A2. If the mean were not 0 and the standard deviation were not 1, I would not be able to immediately use table A2 because then I'd first have to find the z-score. So we already have the z-score here, and what we're looking for is this shaded area, all right? Now this table A2 can only give me the area to the left. So what I'm going to have to do is I'm going to have to find the area to the left, area to left, to the left of this z-score, which is what this table gives me, and I'm going to have to subtract that value from 1 because in fact that area is going to be the complement of the other area. That probability or the white area is going to be the complement or the complement of the shaded green area. So we need to find this z-score. And the way this works is notice that the z-score is rounded to 2 decimal places. And what we're going to do is we're going to look for the ones place and the tenths place in this first column of the z-score table. So in this column right here, in this column, I'm going to look for the ones place, which is 0, and the tenths place, which is 7. And notice these are the negative z-scores. On the other page of this table, there are the positive z-scores, but because mine is negative, I'm looking on the negative side. And here I found the row that has my 0 for my ones and my 7 for my tenths place. So I'm going to be looking at this row right here above this black line. So I'm looking at the row above the black line where I have my where I found my ones place of 0 and my tenths place of 7. Now I'm going to look at finding the hundredth place across the top here. These values represent the hundredth place of a z-score. So I'm going to look across the top here for the number that's in the hundredth place of my z-score, and I see the number in the hundredth place of my z-score is a 5, and here I see the column that has 0.05 where 5 is the hundredth place. So I'm looking for that column, and what I'm doing is I'm looking for the intersection of the row that has my ones and tenths place and the column that has my hundredth place, and the intersection of that row and that column will give me the area to the left. So the area that I'm looking for is this area right here, 0.226. The area to the left, the area to the left is equal to 0.2266. But what I need is I actually need the area to the right, this shaded area. So in order to find the shaded area, this area right here, in order to find that area, what I'm going to do is I'm going to take the area to the left and I'm going to subtract it from 1. So I'm going to have 1 minus 0.2266. The area is equal to 1 minus 0.2266. So the required area is 0.7734. So there we've used the table to find a specific area. We're looking at the area to the right here, and the area to the right is 0.7734. So that's one way that we have to find the area if we're given a z-score. Now, that's using table A2. Another way of finding area given a certain z-score is to use some technology. You can either use the TI-83 or 84 plus calculators, or you can use Excel or Minitab or StatsDisk. But I'm going to show you the procedure for using the TI-83 calculator to find the areas if you're given z-score. All right, so once again, find the area of the shaded region. The graph depicts the standard normal distribution with a mean of 0 and a standard deviation of 1. So we want to find the area between a z-score of negative zero point 0.9 and positive 1.6. We're looking for the z-score for this um, area here. We're looking for, or sorry, we're looking for the area between those two z-scores. We're looking for this area in between. All right, so if you take a look for the TI-83 or 84 plus calculator, what we have is in order to find the area, we're going to press second vars, and we're going to come up with the function that says normal CDF. That's the normal cumulative density function, and it's going to bring up a um, function on our screen, and we're going to type in the left z-score, which is this one here, and put a comma between it and the right z-score, which is this one over here. So this is the left z-score over here. This is the right z-score over here. We're going to put those into our function separated by comma. So let's go ahead and do that. First, we'll bring up our TI-83 plus calculator, okay? And the directions say that what we need to do is we need to go ahead and let's see. It says we need to go ahead. Oops, kind of busy here. Let's get rid of that. All right, and let's bring this down a bit. Okay, let's get the eraser in here. Eraser. All right, so this is what we're doing. What we're going to do is we're going to go ahead and we are going to do this calculation. The lower is going to be, or the left z-score, sorry, the left z-score is going to be negative zero point 0.9. This is going to be the left z-score. And the right z-score is going to be 1.6. This is going to be the right z-score. HT. And we're going to put those into our TI. All right, so let's go. All right, what this says is that we're going to press second, which is this key right here, second. And after we press second, we're going to hit vars. So hit vars, and we're going to select number 2, which is the normal CDF. So I'm going to scroll down, or you can just hit the number 2. And it comes up with the normal CDF. And what I'm going to enter is I'm going to enter, let's see, the left z-score. The left z-score is negative zero point 0.9. So I'm going to do negative 0.9, and then I'm going to press the comma button here, and then I'm going to type in 1.6, which is the right z-score. So I've entered the normal CDF, I've entered the left z-score negative zero point 0.9 and the right z-score 0.6, and now I'm going to close my parenthesis and press enter, and it gives me the area between these two z-scores. This area in the middle right here is telling me that this area is equal to 0.7611. All right, so that is how we're going to find area if we are given z-scores using the TI-83 or 84 plus calculator. You need to know the lower z-score, the upper z-score. You plug them in to the normal CDF function separated by a comma and press enter. Okay, so the next thing we want to do is assume that instead of being given z-scores, we're given an area. So the area is going to be given in this case. The area is going to be given. And what we're going to be looking for is we're going to be looking for the z-score corresponding to that area. All right? So let's take a look here. In exercise 13 through 16, find the indicated z-score. So now instead of being given a z-score and looking for the area, we're being given an area and asked to find the z-score. The graph depicts a standard normal distribution with a mean of 0 and a standard deviation of 1. Now that information is given so that we know that we can use table A2. So here's table A2. And what we have here is we have the area. Now the areas are all in the body of the table here. These are all the areas, and this is what I've been given. I've been given an area, and what I'm asked to find is a z-score. Remember, the z-scores, the ones and tenths place is along this column, and the hundredth place is along the top row. So what I'm going to do is I'm going to actually look in the body of my table where the areas are. Remember, these are the areas. I'm going to look at the body of my table where the areas or probabilities are, and I'm going to look for the closest one to 0.2546. 0.2546. Well, let's see. We have point threes. Uh, let's see, 0.24. 0.25 is here. 0.2546. Here I found the exact number. 0.2546 as an area. And that corresponds to a z-score. If I follow 0.2546 out to the edge out here, I see that that is actually 0.6 for my ones and my tenths place. And if I follow it up to the top, I see that it's 0.06 for my hundredth place. So combining those numbers, I get negative 0.6, and then I'm going to use the hundredth place as the 6. So I found the area, and then I found out which row and column intersect to make that area, and I just turned that into my z-score. So I found the z-score for the given area. All right, now let's say I wanted to do this using technology instead. I wanted to find the z-score using the TI-83 or 84 plus calculators. Well, here is another problem, and in this problem, we're asked to find the z-score, and it says the graph this depicts standard normal distribution with mean of 0 and standard deviation of 1. And here are the directions on how to do it on the TI-83 and 84 calculators. To find the z-score corresponding to the known probabilities, press second vars, the same way we did the last problem, but instead of going to normal CDF, in this case we're going to go to inverse norm. Inverse INVNORM, in norm or inverse norm, and then we're going to enter the area to the left of the z-score. This is very important. We need to enter the total area to the left of the z-score. For example, the command inverse norm of 0.975 yields the z-score of 1.95999 blah blah blah, which is rounded to 1.96. So what we're going to do is we're going to do number 16 here, where we're actually looking for the z-score here, and we're not given the area to the left like this implies we should put into the calculator. We're given the area to the right. So remember here we have the area to the right, area to right, and we need to put into the calculator the area to the left. So if I want the area to the left and I know the area to the right, what we need to do is remember that the total area under this curve is 1, and all we have to do is subtract our area to the right, 0.9418, from 1. So the area to the left then, the area we need, area to left, the area to the left, oops, area to left is equal to 1 minus 0.9418. The area to the left is then 0.0582. So what I'm going to do is I'm going to go to my TI-83 and I'm going to type in inverse norm, it's a capital I believe. So I'm going to type in norm, and I'm going to plug in 0.0582. So this is the command that I'm going to tell the calculator, and it's going to spit back out a z-score for me. All right. So let's go ahead and get that started. All right. So we'll bring out our TI-83. What we're going to do here is we're going to go ahead and we're going to follow the directions, hit second. So we need to turn it on first. All right, let's clear it actually. So we're going to hit second. Then we're going to hit vars. Vars is right here. We're going to go to distributions. In norm is number 3, so you can either go scroll down to 3 or you can just press the number 3 for inverse norm. And then when you get inverse norm, what we're going to type in is the number 0.0582. So we're going to type in 0.0582. 0.82 and close the parenthesis, and it's going to give us a z-score corresponding to that area on the left. So we have that this z-score is actually equal to, oops, we lost our calculator there. The z-score is actually equal to negative 1.57. We round z-scores to two decimal places, so this is negative 1.57. All right, so that's how we find z-scores using technology. Now here's the last thing we want to talk about, and this is some notation that we're going to be using. This is the notation for the critical value. The expression z of alpha denotes the z-score with an area of alpha on its right. So the subscript alpha is going to be a number, and we're going to be looking for the z-score with the area of alpha on the right-hand side of it, okay? So here is an example, finding critical values in exercise 41 through 44, find the indicated value. So we're looking for the z of 0.02. So alpha in this case, alpha is 0.02, the subscript of this number. And what we're looking for when we're finding the critical value is we're looking for the z-score with an area of 0.02 or alpha to the right. So drawing a picture, my art isn't the greatest, but here's the bell curve. And what we're doing is we're looking for the z-score. So we're looking for this z-score, and we're looking for the z-score that has an area of 0.02 on the right. Now I'm going to use technology here. I'm going to use the TI 83 plus calculator, and what I'm going to do is I'm going to have to put in what the area to the left is. So what I'm going to actually end up putting into the calculator is inverse normal. Let me get this out of the way. Oops. What I'm going to put into the calculator is inverse normal, INVNORM. I'm going to put in inverse norm, and I'm going to put in 1 minus 0.02 because I want the area to the left, and what I have is the area to the right. So anytime you're calculating a critical value, you're going to have to subtract from 1, and in fact, we're doing the inverse norm of 0.98. So let's go ahead and do that. Let's bring out our trusty TI. And what we're doing, once again, let's turn it on. Let's clear this. We're going once again to second, vars, and then we're going to number 3, which is the inverse norm, number 3. It asks us, what do we want to find the inverse norm? Remember, our area is 0.98. The area to the left is 0.98. So I put 0.98, close my parenthesis, I press enter, and I get negative, or positive actually, positive 2.05. So the z-score in question here, the critical value, is 2.05, and I've answered question 44.